Okay, so in our video today, we're going to talk about a common question relating to log graphs and how you can quickly solve these. So I'm sure by now you would have seen many similar questions where you've got sort of typically 4 letters and you need to identify which letters are constants. So in this case, this is A and B. They will tell you in the question, which means that T is sort of the input and P is the output, the independent and dependent variables. And you typically get given this as an exponential or a polynomial where you've got T as the power or the base, and you need to do some work with logs. So the standard way that I would answer this question is I get in the habit of applying logs. So we use log base 10 in these kind of questions with Excel. So log P equals log of AB to the T. Then we use our power rules. So we say, our log rules even. So we're going to say that this is the same as log A, okay, plus log B to the T. And then I'm going to go one step further than that, and I'm going to bring that T down as well. There's lots of ways you can write this. I'd like to sort of maybe do something like this, because once we apply logs, the next part of the question, we have to typically match it up to a straight line. A straight line here, if I write y equals mx plus c, well, it's not the nicest thing in the world to compare to. So I'm going to do one extra step. I'm going to write my log A over here, and I'm going to write log B in the brackets with T. I'm doing that deliberately to make it obvious that I don't want to use any log rules accidentally or anything. But I find this format is a little bit more helpful, because typically we're meant to realize that the C element on any straight line would be equal to log A. Okay, and then this one changes depending on the model that you've got. So here, X is sort of the independent variable and T is going to be in this question as well. So what this is telling you by these sort of being next to each other in this format is it's saying that log B is the M value, the gradient value in your question. So you apply logs, you sort of move around the pieces, make it nice and clear, and then the rest of the question really is just going to follow from using these results. So let me show you what I mean. So they say that there's a linear relationship. Well, that's where the straight line comes from. It passes through these points, right? So 0, 4.2. So 4.2 is the C value then, isn't it? So let's use this first result here. So A, which is a value that I don't know, will be the same as the y-intercept, which is 4.2. So can you see that when you do that, if you do 10 to the power of on both sides, 10 to the power of 42 is whatever the A value is supposed to be. And for this one, that should give you an A value. Oh, hang on a moment. I don't actually have that value in front of me, so let me just work that one out. So that's going to be, what was that? That's 10 to the power of 4.2. So I get 1,000. Oh no, I do have that value. So I get 15,000 even, 15,848. What do they want here? They want the exact value of A. So actually I'll keep this one here. Okay, but it's just a little bit under 16,000 for the A value. Okay, and how about the gradient? So if I go back here, I've got 2 points, haven't I? Well, if I've got 2 points, what I can do with that is I can use those points there to get the gradient. Yeah, I can do the difference in y and the difference in x. And if I do that, that will get me a gradient value of minus 0.112. So in this model here, what will we have to do? Well, again, that's saying that log B is equal to minus 0.112. So if you want to know what B is on its own, you need to do 10 to the power of on both sides. and you'll get that b is equal to, and this one they did want to 3 significant figures. This one is going to be, let's just type that in, 10 to the power of minus 0.112. So I get 0.773. Okay. So what do you do then once you've got these? Well, they've asked us here for a complete equation. So that's quite a common question. So that means you write the thing again, but with all the constants that you know written in. So A is exact form, they want this. So I'm going to write 10 to the 4.2, and B is 0.773 to the power of t. So that's what we would have to do, something like that. So applying the log rules from whatever they give you at the start and matching it up, I always find is a very, very quick way of answering these questions. There's another one there on the screen for you to pause and have a quick go at. And you should have found that you applied logs as follows. You had to undo the log with a minus 0.07 to get a 0.851. And you had to do the same step again with 3.9 to give you 10 to the 3.9. So this is what we're looking at here as our complete equation.